All right, 13, 14, and 15. We are going to do a confidence interval for the ratio of the population variance. And again, we're going to have some formulas that we're going to use. On this one, you don't have the plus or minus option. You have to do the two formulas separately. So what they look like is this. We are going to do s squared sub 1, which is our standard deviation, over s squared sub 2, again, that's the standard deviation, times 1 over, and we're going to do an F test, so we're going to do F alpha divided by 2. That's going to give me my lower limit. To do my upper limit, I'm going to do, the formula is going to look pretty close to the same thing. S squared sub 1 over S squared sub 2 times 1 over, and this is going to be F, and I'm going to do 1 minus alpha over 2. So it says, an examination in biology has been taken by biology majors and also by some students from other majors. It is widely believed that the scores for both groups are normally distributed. A random sample of 27 examinations completed by biology majors and an independent random sample of 15 examinations completed by students from other majors are selected. Among the sampled students, the biology major scored a mean of 520.5 points with a variance of 9,781.2. And the students from the other majors scored a mean of 506.4 with a variance of 11,685.6. We're going to do a 90% confidence interval. So again, if we're doing 90% confidence interval, it's 5% here and 5% here. So here, this is going to be 0.05. Here, I would do 1 minus 0.05, which would be 95, right? If I'm at 5% on one end, the other end's going to be 95%. So 0.95 is going to go there. So the S squared 1 is actually going to be your variance, because your variance is your sample deviation squared. So it tells me my variance for my first one was 9,781.2. My S squared sub 2, again, since they gave me the variance in this problem, I have 11,685.6. So if they give me the standard deviation, I have to square it, but since they gave me the variance, it's already squared. And so I just get to plug those numbers into my formula. So for this formula here on the top, I'm going to take my 9,781.2 divided by my 11,685.6 times 1 over, and then I'm using the F option, sub 0.05. Do I have to have degrees of freedom in here? Yes, I do. I figured I did. For my degree of freedom. On my degree of freedom here, let's see, N1, I had 27 in my sample, and 2, I had 15 in my sample. For my degree of freedom, I am going to do N minus 1. So for my degree of freedom in my numerator, I would do 27 minus 1. Which is 26. For my degree of freedom in my denominator, I'm going to have 15 minus 1, which is 14. So number sampled for my first one was 27. Second sample was 15. We minus 1 for each of those. So degree of freedom in my numerator was 26. Degree of freedom in my denominator, 14. I don't even know that I actually need the brackets around that, but they put it there in the formula. You probably don't even need those. That's what you're going to type in to get your first answer, your lower limit. So 9,781.2 divided by 11,685.6 times 1 divided by the F sub, which is over on the right, yep. And we would use 0.05. The degree of freedom in my numerator is 26. In my denominator is 14. And so my lower limit is 0.3.
Are we doing 2?
Yes, 2 decimal places.
0.36.
Okay, 0.36. Now, instead of having to retype all of this, if you just hit undo, you can change your 0.05 to your 0.95 in order to do your other problem. Because it's the same problem, we're just going to change it to 0.95. So 9,781.2 divided by 11,685.6 times 1 over F sub 0.95. Degree of freedom in my numerator, 26. In my denominator, 14. But if you just hit undo, you can just change the confidence level from 0.05 to 0.95. 1.75, exactly what we should get, 1.75. Okay. So, S squared is your standard deviation squared, which is your variance if they happen to give you the variance in the word problem. Number 14 then. Oh, they did give us the squared again. They gave us our S squared. Random samples are drawn independently from 2 normally distributed populations, and the following statistics are obtained. N1 is 11, N2 is 19. We don't really need the mean for our formula, even though they gave it to us. And then our variances, 216.1 and 338.1. So plugging those into our formula, S1 squared is 216.1 divided by S2 squared, 388.1. Times 1 over F sub. We are doing a 90% confidence interval. So for our lower one, we're going to use 0.05, right? Our degree of freedom in our numerator. The degree of freedom in numerator is our number for group 1 minus 1. So since we had 11 here, 11 minus 1 would be 10. Our degree of freedom in our denominator. Group 2, we had 19. 19 minus 1 would be 18. So there would be our first formula. The second one's going to be the same thing, just changing our 5% to 95%. So 0.23 is our lower limit. .56 should be our upper limit, exactly. All right, one last one on this page. Actuaries use variance parameters when evaluating the cost of life insurance. The variance of the lifespans of population is one of the parameters used for the evaluation. Each year, the actuaries at a particular insurance company randomly sample 25 people who died during the year, with the samples chosen independently from year to year, to see whether the variance of lifespans have changed. The lifespan data from this year and from last year are summarized below. So the current year, the average age was 75.7. Last year it was 75. My variances again, 50.4 and 47.6. And so we're just going to plug those into our formula. Again, they already squared them for us. So we have 50.4 over 47.6 times 1 over, are we doing 90%? Yep, we're doing 90% on all of these. So F sub 0.05. My degree of freedom in my numerator is going to be how many people did they sample? 25, so 25 minus 1 would be 24. And then in my denominator, it's going to be the same thing because they did 25 each year, right? So 25 minus 1, again, it's going to be 24. So they sampled 25 each year, and 1 is going to be 25, and N2 is also going to be 25. So my degree of freedom is N minus 1. All right. And then, of course, you're going to do that for the lower limit, and then the same thing to get my upper limit, only I'm going to use 95% instead of 5%. All that in there.
$0.53.
0.53 then is my lower limit. And
2.10.
2.10 is my upper limit.